Okay, this is our first Charles law problem. This first problem is a conceptual problem, which means you don't need an equation to solve it because it asks for how many times larger or smaller things would be. So this is a factor problem. So we're looking for the times that it will be. We know that this is a Charles law problem because it talks about volume and temperature. So remember, Charles' law has to do with volume and temperature. And we know that the temperature is changing from 100 to 300 K, and it asks us what the volume would be changing by. Okay, so the first thing we have to do is figure out what factor the temperature is changing by. And so our temperature went from 100 to 300 Kelvin. So that means it went up by 3 times. Okay. If you can't do the math in your head, you can always take your two numbers and divide them. So 300 divided by 100 is 3. Then the next thing we need to know is we need to know the relationship that exists in Charles' law. So in Charles' law, the relationship is a direct relationship. They are directly proportional to one another, which means that as temperature increases, the volume increases as well. So what that means for us then in this particular problem is if temperature got 3 times larger, the volume is also going to be 3 times larger. Alright, and in our practice problem number 2, we're given that a sample of gas has a volume of 1.65 liters at 25.1 degrees Celsius. Alright, so you need to know that 25.1 degrees Celsius is temperature. It asks us what the volume is, so there's our unknown, at a temperature of 75.4 degrees Celsius. Alright, so givens, we have an initial volume, and we know this is the initial volume because it says that the sample of gas has this, and then it asks us a question as the temperature changes. So we know the initial volume is 1.65 liters. Okay, and then we are given the initial temperature. There's a problem though. Temperatures in gas law problems can only be in Kelvin to do the actual algebra in the equation, which means we need to convert Celsius into Kelvin. 0 degrees Celsius is equal to 273 Kelvin, so the easy way to convert is just remember that you need to take your Celsius temperatures and add 273 to it. So 25.1 plus 273 is 298.1 Kelvin. We need to do the same thing with the final temperature that we are given as well. The final temperature that we are given is 75.4 degrees Celsius. Which is 348.4 Kelvin. Okay, so remember, and if you need to underline or box or highlight, whatever you need to do, that you need to use these Kelvin temperatures when you're using the problem and not the Celsius temperatures. We know that we're looking for the final volume, which is V2, and we know our units are going to be in liters, and the reason why we know the units are going to be in liters is because our initial volume is in liters, and they have to be the same. So plugging into the equation, this is Charles' law. We're dealing with volume and temperature. And the equation for Charles' law is V1 over T1, or initial volume over initial temperature, is equal to the final volume over the final temperature, or V2 over T2. Then we just need to substitute in. So our initial volume, if we look, is 1.65 liters. Our initial temperature, remember you need to use Kelvin, is 298.1. And again, you don't have to write the units if that confuses you. And then we are looking for the final volume, so we just write V2. Please don't do a question mark or something else. Write the actual variable that you're trying to solve for. And we know that our final temperature is 348.4 Kelvin. So we put that in on bottom. Okay, so the easiest way to solve a problem like this, where you have two fractions, is to cross multiply and divide. And I'm going to do the solve over here because I've run out of room. So I'm just going to rewrite this so that I have the numbers on this side. 298.1 equals V2 over 348.4. Okay, so again, we want to cross multiply and divide. So what that means is we are going to be multiplying 1.65 times 348.4, and that's going to equal 298. Let me erase that. That's kind of ugly. Try that again. 298.1 times V2. Okay, so there's our multiply. Now we can simplify this side over here by multiplying these two numbers together, and when you multiply 1.65 times 348.4, you get 574.86. Now, if you happen to get a number on one of these problems that is a big long number on the calculator that goes out way past the decimal, you need to at least take it a few places past the decimals so that you don't have error in the end of your problem when you go to do your significant digits. Alright, so that number, 574.86, is equal to 298.1 times V2. And then remember I said this is cross multiply and divide, so now our step to solve for V2 is to divide both sides by 298.1. So that cancels out the 298 on the right side of the equation, and then we take our 574.86 and divide it by the 298.1, and this is where you get one of those big long numbers on the calculator, 1.92841 blah 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 blah. Okay, that's plenty of significant digits there so far, and then we need to do our last step, which is to actually figure out how many significant digits we need. Well, if we look at our givens, okay, our initial numbers that we had, if we look up here, is 1.65, which has 3 significant digits, 2.51, which has 3 significant digits, and 75.4, which has 3 significant digits. So that means that our answer needs to go to 3 as well, because all 3 of these numbers have 3 sig figs. So when we go to do our rounding, the 8 rounds the 2 up to a 3, so this becomes 193, 1.93, and then we need our units on here. We were solving for volume. The units are liters, and that is the final volume, 1.93 liters. And that is how you do a Charles Law problem. Remember, it's very important to make sure your temperature is in Kelvin on any problem that involves temperature in gas laws.